In this third part of lecture on Laplace transform, we are going to see theorems of the Laplace transform. There are two theorems known as initial value theorem and two final value theorem. So these theorems respectively give the initial value and final value of a function f of t. So let us see what are these functions. So let us see what are these theorems. First let us see what is the initial value theorem. So initial value theorem gives initial value. Initial value is f of t in the limit t tending to 0. So f of t in the limit t tending to 0 will be equal to, this is a limit, lim is limit, this is also limit, lim, limit. So limit t tending to 0 of f of t will be equal to limit s tending to infinity of s into f of s, where as usual f of s equal to L into f of t, that is Laplace transform of f of t. So therefore, to use this theorem, the function f of t must be Laplace transformable. Okay, so this theorem simply gives the initial value of a function. That is, if you want to know what is the initial value of a function f of 0, f of 0 is nothing but the function f of t evaluated at t tending to 0. So this, by this theorem, equal to s into f of s, s tending to infinity. So this is the meaning of this theorem. This is the meaning of this theorem. So this is the meaning of this theorem. F of 0, which is f of t tending to 0, equal to s into f of s. In this, you substitute s equal to infinity. So this is initial value theorem. So let us see now next final value theorem. So final value theorem states almost the same. It gives a final value of the function. Just interchange the limits here. Simple. Interchange the limits, you get final value theorem. So let us see. F of t in the limit t tending to infinity, this is the final value, will be equal to s into f of s in the limit s tending to 0, where f of s is L into f of t. So first condition is, as before, the function f of t must be Laplace transformable, and here there is also an additional condition, which is that this, provided that s into f of s should not become equal to infinity. S into f of s should not become equal to infinity for any value of s satisfying the relation real value of s greater than or equal to 0. I repeat, for this theorem to be applicable, in order to use this theorem, this is the condition. The condition is s into f of s should not become equal to infinity for any value of s satisfying the relation the real value of s greater than or equal to 0. Only when this condition is satisfied, this theorem can be used. S into f of s should not become equal to infinity. If s into f of s is equal to infinity for any value of s greater than or equal to 0, then this theorem cannot be applied. Okay. So simply this, again, this means this gives the ultimate value of a function. The ultimate value of a function is f infinity. So f infinity can be found normally by f of t at t tending to infinity. It can also be found by s into f of s at s equal to 0. So the advantage of these theorems will the advantage when you go to control system analysis, you can find the initial and final value of the functions. You can find the initial. Normally, how do you find initial value of function? By substituting f of t in the f of t equal to put equal to t equal to 0. So to find f of t, you find f of initial value, you'll be finding it by this. In f, you'll find you should have f of t and then f of t put equal to 0. But this theorem says without knowing f of t, we can find the initial value directly from its Laplace transform, f of s into s. In this you put s equal to infinity. Similarly, same way, the final value, which is infinity, this f of infinity, normally you find from this, you write f of t, find you should know f of t, in that you put t equal to infinity. But here you can also directly find f of infinity without knowing f of t. But if you know the transform f of s, you can directly find the ultimate value by this. So the advantage is, one, sometimes this f of s, why sometimes, many times in control system analysis, the f of s will be a complex function or a big function. To invert this, you have to find ultimate. If you have to find the final and initial values, you have to invert them. You have to f of s, from f of s you have to find f of t, and then you have to put t equal to infinity, inverse. But that will be a tedious procedure, lengthy procedure. So we can cut short that procedure and we can save time by using these theorems. Directly from the Laplace transform, multiply the Laplace transform by s and put s equal to 0, you are going to get the ultimate value f infinity. That is, instead of using this route, we can use this route. That will be easy. We need not know what is f of t. So to find initial value and final value, you need not know what is f of t. If you know the f of s, you can find the initial and final values using these two theorems very quickly. So that is the advantage of these two theorems. We will practice examples, and later in control system analysis, we will realize and appreciate the importance of these theorems. Okay.